Dear student, Assalamu alaikum. Welcome to online course Physical Chemistry 2. The topic of today's lecture is photoelectric effect. In this lecture we will discuss what is photoelectric effect, why classic mechanics failed to explain the photoelectric effect, and what is the explanation of Einstein for photoelectric effect. The books which I follow for this lecture is the Advanced Physical Chemistry, D.N. Bajpai, and Physical Chemistry, Era and Levine. So, a photoelectric effect was first introduced by Heinrich Hertz in 1887 when any surface is heated by electromagnetic radiation of high threshold frequency. The radiation will be absorbed and cause the emission of electron. These emission or ejected electron we will call photoelectron, while this phenomena is called photoelectric effect. The current produced a result of ejected electron is called photoelectric current. Photoelectric effect phenomena is one of the important procedure which was introduced in the start of 20th century. Now, if we consider experimental setup which composed of glass chamber and there inserted a cathode, particular metal, and anode. Now, this cathode and anode is connected with the emitter to show or check the current produced due to photoelectric effect. Now, when the radiation like a red light source is strike on the surface of the cathode, no current will be produced. If we increase the intensity means number of photons per unit area strike the surface, still no current will be produced. When we change the source, it means the frequency of the radiation. We go from red light to X-ray, which have different frequency and wavelength. Here, current emitter will show a current and ejection of electron will start. So, as we discussed, we change the intensity of red light, no current will be produced. We increase the intensity of red light, no current will be produced. However, the X-ray has smaller higher frequency. That's why even if we use a smaller intensity, they will cause to produce a current in that material. So, what is the mechanism behind why red light produce a current and X-ray? Either red light doesn't produce a current while the X-ray produce a current. As we know, the wavelength of one wavelength of red light will be 700 nanometer. If we calculate the energy for that wavelength radiation, so it will be is equal to 2 electronic volt. This is the lower energy, while if we calculate using the same formula for the X-ray, which is have 1 nanometer wavelength, now the energy for that 1 nanometer wavelength radiation will be 1200 electronic volt. This is higher energy compared to the red light. That's why it produces a current, while the red light cannot able to produce a current. This experiment we can easily understand. If we take a toy, we put on the table. Now, if we hit this toy with a small ping pong ball, the toy will not fall down from the table. While one ball, a baseball, if we hit the tie by this ball, so it will cause to fall down the tie here. Now, how we can explain further this one? If we consider any system here, the light is coming from that source, fall down on the surface of cathode, so we change the intensity and we change the wavelength. So how they are affecting. For example, this is the lower intensity. We increase the intensity of red light, but no current is producing. We increase the intensity to 97%, but no current will produce. However, if we change the wavelength, as we go to different wavelength, here we see that current ejection of electron will start in that region. So it means that UV light and above will cause the ejection of electron from the surface of zinc. According to classic mechanics, the light will behave like a waves. So wave intensity we increase, the number of ejected electrons should be increased, because higher number of wavelength means greater the electric field amplitude. So this greater electric field amplitude will cause a more potential to cause the ejection of electron, but practically no current is produced. So here classic mechanics fail to explain or give explanation why it's not called the ejection of electron of higher intensity. Then quantum mechanics he said, no matter how bright, how the intensity is, a red light you have, it will not produce a current in the metal. But even a very dim, a very small UV light will result in a current flow. So Einstein gave explanation for that. They using Max Planck's idea that the light electromagnetic radiation is consist of tiny bundle or packet of energy. This tiny particle or packet, they give the name of photon, and he say when this photon is effect on the ejection of electron. So what is the photon? First we discuss this one and then come to the photoelectric effect. Photon doesn't have any mass, charge, and they are not reflected in magnetic and electric field. The photon move with the speed of light in space. During interaction with the matter, radiation behave it made of small particle, which Einstein gave the name photon. Now photon are virtual particle, and this photon energy is directly proportional to their frequency. Higher their frequency, higher will be their energy, and inversely proportional to their wavelength. So the idea of Max Planck's, which give the name to this tiny particle, are quantum. Einstein give the name of photon, this particle, this tiny particle. I here mention some difference between the Planck idea and Einstein idea. Max Planck said that the emitted radiation from the black body should behave like a teeny particle, and they giving this to tiny particle packet of energy quantum wave. While Einstein say that any source of radiation which coming or producing from sunlight and another source, they consist of teeny small particle which give the name photon. Now what will be the energy of this photon? According to Einstein, their energy will be equal to h mu. H is the Planck constant, which is 6.602 10 to about -34, and mu is the frequency of particular radiation. Now we come to again back to the photoelectric effect. So electron, as we know, electron in the matter is surrounded by a revolving around the nucleus, and they are held by the nucleus of the atom by strong bond, which is called binding energy. Now we will need a minimum amount of energy to remove this electron from the surface. This minimum amount of energy to remove the electron from the surface of matter is called work function. So if incoming photon, incoming radiation frequency energy is lower than the work function, the photon will not able to eject an electron from the surface. However, if the incoming photon have energy greater than the work function, electron will be emitted from the surface and energy will be conserved in the process. This will come out by the equation that incoming photon energy will be equal to 1/2 mv square to the kinetic energy of the ejected electron plus the work function. So what will be the speed of ejected electron? This will be equal to 1/2 mv square is equal to hf minus work function. We bring this to the left hand side, so we obtain this one. As we know, different material have different value of work function, different binding energy. For example, silver has 2.4 electronic volt. So this work function will be different for different metal. Generally, elements with the low ionization potential have low work function, such as lithium, sodium, potassium. The first group element have lower work function. Now, the particle theory assumes that electron absorbs a single photon. Now, plotting the kinetic energy versus frequency, if you plot, we increase the frequency in here, what will be the kinetic energy of this photon? So, as we know, we increase the frequency, no photon is producing. Photon frequency is greater than the incoming photon, so no photon is producing. And as we seen in the software that we increase the wavelength but no photon was producing. When after threshold frequency or work function, ejection of electrons start and further increase the frequency, their kinetic energy is increased. As we mentioned in that equation, that some energy of incoming photon will be used in the removing of electron from the surface, and some will be used gained by the ejected electron in the form of kinetic energy. So this is the kinetic energy of electron which is moving, with which the electron is moving. Thank you very much. And next lecture we will discuss black body radiation.